Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have 8 to the power of a divided by 64 is equals to 6, and we solve this problem for all the values of a. So here the very first thing we are going to do is first we will move this 64 from left hand side to the right hand side. It is divided by here. When we move it into the right hand side, it is multiplied by 6 and it will be written as 6 multiplied by 64. So further in the next step, you see here we need a little bit simplifications here, so that here we write it as this is 6 multiplied by 64, and we write 64 as 8 square, and in the left hand side we have exponential term, that is 8 to the power of a. So here for the values of a, we need logarithm, so that here we use the logarithm to find the values of a, so that we apply log on both of the sides, and when we apply log, it will be written as log of 8 to the power of a is equals to log of 6 multiplied by 8 square. So here we need some properties of logarithm, and you know about that. If we have log of x to the power of m, so it is equals to m times of log x. And further we use another property of log, it is if you have log of x multiplied by y, so this is equals to log of x plus log of y. So first we apply both of these two properties to the above equation. So according to first property, we move this exponent in the front of this log, and it will be written as a times of log 8 is equals to, in the right hand side we apply the second property, and this will be written as log of 6 plus log of 8 square. So in the next step, we need more simplifications, and here for the values of a, we need to divide each of these terms by log 8, because we remove log 8 from left hand side for the values of a. So here we divide each of these terms by log 8 in this form. And further you see here this log 8 and this log 8 are cancelled out by each other, and in the left hand side we get a is equals to, here we have this is log of 6, and we write 6 as 2 multiplied by 3, and in the same pattern this is log of 8, and we write 8 as 2 cubed, and plus here we use the first property of log, and we move this exponent 2 in the front of this log, and it will becomes 2 times of log 8 divided by log of 8. And now again we apply the second property here, because this is the product of values inside the log, so that we apply log separately on both of these two values, and it will becomes log 2 plus log 3 is divided by, here we use the exponent property of log, and we move the exponent 3 in the front of this log, and it will becomes 3 times of log 2, and plus this log 2 and this log 2 are gone, and we get here 2 only. So here we need a little bit more simplifications for the values of a. So here we break this fraction, and it will be written as log of 2 divided by 3 times of log 2, plus this will be written as log of 3 divided by 3 times of log 2, and plus here we have this is only log 2. So this log 2 and this log 2 are gone, and we get here 1 over 3. So this is plus 2, which we write in the start of the problem, and here this is log 3 divided by log 2, and we write it as 1 over 3 times of log 3 divided by log of 2. So here we need a little bit more simplifications for the values of for the lowest values of a. So here we need to take the LCM of these two terms, and its LCM becomes here 3, and we get here 1 plus 6, and plus this is 1 over 3, and here we apply another property of log, and we combine both of these two logs, and we write in this form log of 3 with base 2. Okay, this log 3 divided by log 2 is equals to this value. So now here finally we have the value of a is equals to 1 plus 6 becomes 7 divided by 3, plus this is 1 over 3 times of log base 2 of 3. So this is the only one value of a which we get here in this method. And now in the next steps we need to verify that is this value of a be the solution, or is this value of a be the extraneous root. So for verification of this value, first we need to copy down given question statement. Here it is 8 to the power of a divided by 64 is equals to 6. So here we substitute the above value of a here, and we move the 64 to the right hand side, and it will be written as here we first rewrite this equation as 8 to the power of a is equals to 6 multiplied by 64, and now we put this value of a here, and it will becomes 8 to the power of a. The value of a is 7 over 3 plus 1 over 3 times of log 3 with base 2, and here we check that is this equals to 6 times 64 or not. Okay, this is our claim. So here we need more simplifications, and we write it as 2 cubed, and further we break its exponent, and it will be written as 2 cubed, and its whole exponent is 7 over 3 times. Again we have 2 cubed, and its exponent is 1 over 3 times of log 3 with base 2, and we check that is this equals to 6 times 64 or not. So here you see that this 3 and 3 are gone, and we get here 2 to the power of 7. So here you see that this 3 and 3 are gone, and we get here 2 to the power of this is log of 3 with base 2. When we check that is this equals to 6 times of 64 or not. Okay, so further we have you see that this log with base 2 and this 2 are cancelled out by each other according to the nice property of log, and we have this is we have the remaining values are 2 to the power of 7 multiplied by here we get 3, and we check that is this equals to 6 times of 64 or not. So here we break this 2 to the power of 6 as in this form. We break 2 to the power of 7 as 2 to the power of 6 multiplied by 2 and multiplied by 3 is equals to 6 multiplied by 64. And here you clearly see that 2 to the power of 6 is equals to 64, and 2 times 3 becomes 6 multiplied by 2 to the power of 6 is equals to 64. So here we obtain 6 times of 64. So you see that both of the sides are equal. It means that the above value of a, that is equals to this one, is satisfied our given question statement. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more interesting and exciting videos.